Right, hopefully you can see that all right. It's at a bit of a funny angle. Right, so I've looked through the crossover for these speakers and I'm going to draw it out, but what I'm not going to do is put the values in there, because I'm mindful that this is probably a speaker that is in production and this is someone else's intellectual property, so it's not for me to start spitting out all the crossover component values and things like that. I've become aware of this with my own speaker design, so yeah, got to be respectful of that. So let's draw out this crossover. So positive and negative. Obviously we're on two individual boards, one for the mid-range circuit purely, and then the other is doing the tweeter circuit and the woofer circuit. So what we'll do is draw these out. So if we look at the tweeter circuit first, we come in to a resistor, and then we come into a capacitor, carry on to another capacitor, and in between those we ground out an air core inductor. Then we carry on to the positive of our tweeter. I'll draw this out and then I'll go through my thoughts and what I probably need to do. Mid-range circuit is quite complicated. So we come in through a resistor initially. So these resistors here are going to attenuate the circuit as needed. These values are not high enough. Then we come in through an inductor. So this is really limiting how high up the mid-range plays. Then we have a capacitor. We come into another capacitor, which is an enormous value, and in between here we are grounding on a capacitor and an inductor through a resistor down to ground, and then here we hit our mid-range connected in phase, mid, and then across that we have a resistor. Dear, he's leaked one of the values, naughty boy. Right, woofer circuit, coming through an air core inductor, which is not a very big value, and this is the circuit that has surprised me on a three-way. It's more like a two-way. Positive of our big woofer, and then we have an enormous, huge, great cap value through a resistor. What I'm not particularly liking on the woofer circuit is the use of a smaller inductor and then a really large shunt capacitor. So we're using a lot of grounding to roll off our woofer rather than a large value inductor. And I can understand that to a degree, because if you want this to be an air core inductor, large values are going to be very expensive. But this isn't how I would go about this. More shunting frequencies to ground rather than actually using an inductor and rolling them off through the resistance slope of this. The tweeter circuit, I was quite happy with the way that looked, but we had this peak. I can't remember what it was. Hang on a minute, let me just have a look on the old computerizer. About 3 to 4 kilohertz, and that peak was in the tweeters range, not the mid-range. The mid-range circuit rolls off nicely top and bottom actually, so other than some attenuation, I don't want to play with a mid circuit because I can see issues in the tweeter circuit and the woofer circuit, so I'd rather leave that alone and play with these. So that peak I'm seeing between 3 and 4 kilohertz, I would imagine has got a lot to do with this shunt inductor here. It's probably requires a resistor here because it's shunting too much power to ground, and that's creating that spike. Otherwise its roll off is pretty damn good, and that with some attenuation on the mid-range and the tweeter can probably meet each other quite well. So really I'm going to try that, and then I'm going to clip this woofer circuit together on the bench and redo this. For me, a second order filter on this three-way design is probably too shallow. We probably need to be a bit steeper, like a third order, to get some baffle step correction there. So yeah, I think that's what we'll be doing next. Right, back to the hooky old drawing, I'm afraid, and I'll show you what I've had to do. I'll go through the new measurements in a minute, but yeah, worked out pretty well really. This resistor value here, which was very small, that's all I'm going to say, has now changed to a 6.8 ohm, and I've also introduced a 1 ohm resistor on the shunt inductor, as I thought that was creating that peak. Just introducing that has just pulled it down. All is good. Third order arrangement on our tweeter circuit. The mid-range was a circuit I wanted to keep the same. This resistance value here I've increased to 10 ohm. Our woofer circuit, which was second order, I've changed to a third order, and this has worked out quite well. So as I've done my own design for the woofer circuit to integrate it, I can tell you the values. So I've used a 4.5 millihenry inductor. I've voiced it with an iron core because this is a very big value and I need a low resistance. So I'll talk to David about keeping that iron core because we're right low frequency, or I'll probably have to custom wind that to get the DC resistance I need and that value if we do it as an air core. So at the moment that's 1 ohm. Then I've introduced another inductor here because, like I say, I've turned it into a third order, and that is 2 millihenry, 1 ohm again, and I've used a 100 microfarad capacitor with a 1 ohm resistor, and that's worked out brilliantly. So I will go through the measurements now. I've measured as low as I can in the office because it's crappy outside. But yeah, we'll go through that now. Right, hello again. After well, the majority of a day mucking around with these. Hey Pussycat, you say hello? That's my cat Oliver. He's normally with me. Doesn't like the measurement noises, but he tends to tolerate it. Yeah, so after most of a day working on these and doing buttloads of measurements for the integration of this woofer correctly, I think it's turned out pretty well. Yeah, and I've listened to them as well, and there's meat to the sound now. The HF, the mid-range, the body of the woofer, it's all there. So really pleased with them. So before we get started, I'll quickly put up the original on-axis measurement without any form of baffle step and with the levels all wrong for the drivers. And on axis, this is what we have now. I mean, I've traded a little bit of sensitivity to get this right, but really I'm going to say from 200 Hertz all the way up to 15 kilohertz we are plus minus 1.5, maybe 2 dB, really good. And we've got that ever so slight recessed mid area that just stops a speaker being harsh and they sound lovely. The tweeter level is now down and balanced. If you look at it and see it's a little wavy, it's because I'm measuring inside in a small room. I'm gating these measurements, but that really isn't there. So as soon as I can measure these when I put the finished crossovers together outside, I will. Here is the new cumulative spectral decay, which is one of the cleanest I've seen. So these drivers are really quick. They are really nice. Let's look at the vertical. Given the spacing of these drivers, I'm quite surprised how well everything holds together. As we get 20 degrees above this tweeter, so bearing in mind we are a meter, 20 degrees is a hell of a lot, especially when you move further back. We do begin to develop a bit of a peak at about 900 hertz, but I can't see you ever being up there. And at 10 degrees, it's pretty much the same as on axis, which is what we're after. Our crossover points are about 3000 hertz from here to the mid, and then about 420 to our woofer now, I would say. The mid-range circuit, other than a bit of attenuation, I've kept the same. The tweeter circuit, I've added more attenuation and resistance to the shunt inductor, and the woofer circuit is completely redesigned as a third order now. So now if we look at the horizontal measurements, you can see that, I mean, they're really consistent now, and it took quite a lot of mucking around with parts to get that as good as it is. I mean, sometimes you have to compromise a little bit on axis for the off axis. I mean, most people don't sit in the chair and point their speakers right at them. When you've got good off axis performance like that, especially horizontal, the room interaction is going to be very consistent, and you don't need to toe them in that much, and that gives you a broader listening area for other people sitting around as well. So I always kind of prefer to maybe compromise on axis slightly for better off axis performance, and that's really good. Impedance, it's largely the same. It's probably gone up a little bit. We're more like a 5 ohm minimum load now, rather than, I think we were just below that, 4.5 or something before. So yeah, and obviously the port tuning is the same. The peak impedance is about 22 ohms like it was before. So all in all, really good, and we're maintaining good off axis because we're playing this as low as we can, playing that as low as we can, keeping the wavelengths we're crossing between drivers as wide as we can or as long as we can, and that really helps. So yeah, I've got to order, what are you doing, Kat? I've got to order some parts for the woofer circuit, see what's available, because I'm using a big value inductor, and getting that in an air core version is going to be tricky. I'll probably end up having to wind that to keep its DC resistance low, but yep, well pleased, and like I say, they sound good. So at some point I'll get them both back together and have a listen to them. Not that I'm looking forward to lugging them into the lounge. Catch you soon.